in the previous year 2023, and the subjects that we'll be covering today is related to the programming, data structures, and algorithms. Okay, yeah. So first we'll be discussing the questions related to the algorithms, and then we'll be having the questions related to programming and data structures. Okay, yeah. So let's get started. So, my dear students, the first question is related to the asymptotic notations. So let's read the question. I'm giving you a minute to think about it, and then we'll see the solution. Okay. So F and G, they are the functions of the natural numbers represented like f of n is equals to n, and g of n is equals to n square. So which of the following statements is are true? So its first option is related to the big O notation. Then second is like third is little o, then theta, then omega. Okay, so yeah, so this is big omega. Okay, this is little o, this is little o notation, and this is theta notation. Okay, yeah. So which of the following options is correct? It's a multi-correct question, students. It's an MSQ question, so more than one options can be correct. So yeah, what can be the question answers, guys? Come on. Yes, students. Yeah. So f of n is equal to n, okay, and g of n is equals to n square. So we know that f of n is like equivalent to big of g of n when when it will happen, guys, when f of n is when f of n is like we can represent it on the form c into g of n. Okay, when we can represent like for any constant c and for any n greater than n naught, when this works, then we say it is correct. Okay, so now f of n is n and g of n is equal to n square. So can I say that f of n can be equivalent to big of g of n? Why? Because g of n is an increasing function. Like n is like f of n is linear, g of n is quadratic. Like for larger values of n which will be bigger, g of n will be bigger. Okay, so that's why a option is correct. Okay, yeah. So what can be the other option correct? Can I say if big O is working, like if big O is there, so similarly for this scenarios, can I say little o will also work? Little o, which is the third option, will that also help? F belongs to little o of g? Yes, because in big O notation, what will happen in big O? There is a concept of equality. Okay, but in the case of little o notation, they won't be equality. It will be strictly greater. Okay, so can I say that f of n in this case, n is strictly greater than n square? Let's say n is strictly smaller than n square. Can I say that? Can I say that n is strictly smaller than n square? Yes. So that's why I can say f of n belongs to little o of n square also. This is little o, students. Okay, this is little o. Yeah. Okay. So f of n belongs to little of n square. So hence C option is also correct. Okay. So yes, A and C are correct for this questions. Okay. I hope you got it correct. Yeah. Yeah. Let's discuss the next question, students. Consider functions function 1 and function 2 expressed in the pseudocode as follow. So please read the pseudocode. Now let f of n and f2 of n denote the number of times the statement x is equals to x plus 1 is executed. Okay, so number of times this statement and this statement is executed. Okay, so now the question asks is that which of the following is true? Like what is the relation between f1 of n, f1 n, and then f2 of n? Okay, so I'm not disclosing the options. I want you to first look into the question and find out what is the relation, like how many times x is equals to x plus 1 is executed in function 1 and function 2. Then we'll see the solution. Okay, then we'll see the options. Come on, try. Yes, students. Okay. So yeah, let's discuss this scenario. Can I ask one thing, like how many times like this while loop, outer while loop is getting executed? See, first we are having n is greater than or equal to 1. Say, let's say n is equal to 10 was there, or let's say n is equal to 32 was there. Okay. N would have been 32. So every time what is happening, here, students, is that for this scenario I'm saying, okay, so what is happening, that n is equal to 32. So if 32, like my for loop would have been executed 1 to n. Okay, then what I'm doing, I'm decreasing the value of n by half. So n initially value would have been 32, then 32 by 2, it would have been 16. Then can I say it would have been 8, then 4, then 2, then 1. So can I say, students, that the function 1 would have executed how many times? Like the inner part of x is equals to x plus 1. First it would have executed n times, then it would have executed n by 2 times, then it would have executed n by 4 times, then n by 8, then n by 16, all the way up to 1. Okay, so this is which comes, like this is which progression, students? Come on, this is which progression? This is GP. Okay, this is a geometric progression. So when you sum up this, what value will get? We'll get close to the value of, like approximately we'll get 2n. Okay, order of, like you can get some precise value 2n minus some constant. So but what is the order of function 1 in this case? How many times the x is equal to x plus 1 is getting executed? Can I say it is order of n? Yes, do you agree with me? It's in the range of n. Yes, yeah. So this is function 1. Okay, now let's discuss about function 2. Let's discuss about function 2, students. Function 2, so how many times it is getting executed? X is equal to x plus 1. Come on, it's very trivial. Say if I'm saying n is equal to 1, so how many times x is equal to x plus 1 will get executed? Can I say 100 times? Because 100 into 1 would have been there. Okay, 100 into 1 would have been there. Then if I'm saying n is equal to 2, so how many times it would have executed? 200 times. So can I say if it is n, then how many times it will be executed? 100 n times. Okay, so function 1 is executed like this many times, and function 2, x is equal to x plus 1, would have executed 100 n times. Can I say that is also equal to order of n? Yes, yeah. So let's check out the options, students. So again, this asymptotic notations, this works for the, like we always assume that for larger values of n, what is the scenarios? Okay, yeah, let's discuss. So can I say it is equivalent to theta? Yes, because f1 of n was also in the order of n, and second function was also in order of n. So yeah, so can I say a function works? Yeah. Little o, will it works? No, because they both are similar, same functions. Okay, it's similar, so that's why second option is incorrect. Third option, little omega, no, because this, like we all know, right? Little omega. Okay, this, they won't have equality. Okay, they doesn't have equality. So that's why B and C are incorrect. Again, D, will it work? Yes, it's big O. Big O, equality is there. So that's why D is also correct. So the correct answer is A and D. Okay? Yes? Yeah. Yes, students, any doubts? Please let me know. Yeah. Let's discuss the third question. It's a very beautiful question with respect, which checks the concept of power set and breadth first search knowledge and all, and what is the corresponding symbols meaning. Come on, students, I'm giving you a minute to think about it. Come on, try. Okay. Let's discuss the let's read the question. So what we have been given, that we have been given a set U. Okay, we have been given a set U, and set U has three elements, 1 2 3. Okay, set U is having three elements, so let 2 power U denote the power set of U. Students, one important question: if I'm given a set of n elements, then its power set will contain how many elements? It is 2 power u. Okay, so here also if I'm having 3 elements, so number of elements in the power set of u will be 8. Okay, yeah. Now consider an undirected graph G whose vertex set is 2 power u. Okay, so now what they're saying that for any a comma b which belongs to 2 power u, a, a comma b is an edge in G if and only if the two sets are unequal. Okay, and either a, what is the meaning of the symbol, students? Come on, what is the meaning of this symbol? It means a is a proper subset of b. Okay, I'm writing this. When we write this, right, it means a is a proper is a proper subset of b. Okay, yeah. So what they're saying for any, yeah, so either a is a proper subset of b or b is a proper subset of a. Okay, so proper subset, we know, like, what is the meaning of proper subset? Like all the elements of a are in b but all the elements of b, they are not in a. That is the meaning of proper subset. Okay, yeah. So for any vertex a in G, the set of all the possible orderings in which the vertices of G can be visited in BFS starting from is denoted by this symbol, beta of a. Okay, now if phi denotes the empty set, then the cardinality of B of phi is, come on, try students, try. It's a little tricky. It's a little tricky. Okay, let's discuss, students. If I'm having US 3 elements, 1, 2, 3. So what is the meaning of 2 power u? Like proper subset of u, or power set, I should say. What is the power set of u? Power set of u will contain what are the elements? Come on, 5 will be there. Okay, now can I say 1 will be there, 2 will be there, 3 will be there. Come on. Then 1, 2. Yes, you got it correct. 1, 2, 1, 3. And then 1, 2, 3. Okay. Yes. So now how can we represent these elements? A, like let's assume that I'm right. I'm representing this with the help of some letters. A, B, C, D, assuming it's E, F, and then G. Okay, now what they're saying that you can take any of the two elements in the power set of U, and then they're saying that there is an edge. There is an edge only if the two sets are unequal, means there is no self loops, or we are saying that A is a proper subset of B or B is a proper subset of A, like for these scenarios. Okay, now, so can I say, please always on the screen, assuming what is a is 5. Okay, and then let me write all the vertex B, C, D, E, F, and then G. Okay, now what they're saying, now let me ask you the following question. Can there be a vertex, can there be an edge from vertex A to vertex B? Can there be a vertex from, can there be an edge from vertex A to vertex B? Come on, students, come on. Yes, there will be. Why? Because this is a scenario, students, that like A can be the proper subset of B, or B can be the proper subset of A. Okay, now the question is empty set, is empty set a proper subset of the rest of the sets of the remaining set? Like for each of the remaining sets, can phi be a proper subset? Yes, phi is a proper subset of all the, like for every set we can think of. Okay, so that's why there will be an edge from A to B. Do you agree? So what it means, that there is an edge from phi to 1. Can I similarly say there's an edge from phi to 2? Yes. Phi to 3, phi to 4, like 5212, then 5213, then 5223. Here we have missed an edge like 23. Okay, then there will be an edge like this. Yes, come on students. B, C, D, E, F, G. So we have 1, 2, 3, 4, 5, 6, 7. Then there will be another edge. Do you all agree with me that 5 will be connected to each and every one vertex? So that's why A is connected to every other vertex. Okay. Yeah. So now let's see the questions. So now what they're saying, if phi denotes the empty set, then the cardinality of B of phi. And what is the meaning of cardinality? Is like number of orderings that are possible. Okay, the set of all the possible orderings in which the vertex of G can be visited starting from A. So in this question, it means that if I'm starting from phi, then if I'm starting from phi, so what are the various BFS ordering possible? Okay, so can I say students that if I'm starting from phi, so what are the like options I have? What are the, I can either go to B, C, D, E, F, G, S. So I have 7 options. Okay, I have 7 options to traverse. Okay, so you can think that I am having 5 over here. Then I can either go to 1, I can go to either 2, I can go to either 3. Okay, then maybe 1, 2, 1, 3. Okay, 2, 3. And I'm writing here 1, 2, 3. Okay, so 5, it can go all the way up to here also. So what are the various possible? We have 7 options I'm having. Okay, so 7 options I'm having, so that's why 7 factorial. Okay, so 7 factorial will be having. So hence the answer to this question, cardinality of B of phi is 7 factorial, which we will compute, which is equal to 5040. Okay, any doubts? Any doubts, students? Yes. Yeah. So now we have covered 3 questions in the algorithms, which was asked in the GATE CS 2023. Now let's discuss the question related to the subjects programming in data structures. Okay, so here we'll be solving 8 questions, 4 questions of 1 mark and 4 questions another of 2 marks. Okay, so yeah, let's get started. So let's read this question. Which one of the following sequence, when stored in an array at locations, form a max heap? Okay, come on, try. What is the property of max heap, students? What is the property of max heap? Parent is having more value than the children. Okay, parent is having more value than the children. Okay, come on, try. Let's discuss it. Let's try to draw the heap for the options. We'll solve it together. Let's discuss the first option. Okay, so let's say 23 is a root, then 17, then 10, 6, 13, 14, 1, 5, and then 12. Okay, yeah. So is this a max heap? Is this a max heap? What is the property of max heap? Parent is having more value than the children. That is the property of max heap. So is it following the max heap property? First option, please, all eyes on the screen. 23. Yes, okay, this is fine. This is also fine, but is this property getting violated? Max heap property getting violated over here? Okay, so A is not the correct answer. Okay, yeah. Let's try to draw the another part. So what they're saying in the second part, right? What they're saying, let's try to solve, let's try to see. Okay, so what they're saying in 23, 17, now I am having 14. So now they're saying that I'm just redrawing, students. So we are having 7, 23, 17, 14, 7, 13. then I'm having 10, then I'm having 1, then they're saying 5, 6, and then 12. Come on, is this a max heap? Is this a max heap? Students, is this a max heap? Let's see. Parent should have more value than children. Parent is having more value than children. Correct. Parent should have more value than its children. Correct. 17 is greater than 713. Similarly, 14 is greater than 10 and 1. Similarly, 7 is 5, 6. 13, 12. So yes, this is correct. So which one of the following sequences when stored in array location forms the heap? So yeah, these correct option. Okay. Yeah. So shall we try other C and D? Because always think that it can be multi-correct also. Okay. So let's see students. So 23, 17, 14. Then they are saying 6, 13. Okay, so they are making it here 6, then 13, then 10, 1, then 5, 7. Okay. So if you type the other way, then this property get violated. So that's why C is incorrect. Okay. Similarly, what they're saying 23, 14, 17, then they're making one value. So similarly, if you will try to draw the tree, it will violate the massive property. So that's why B is correct. Okay. Yeah. Come on. Read the question. Next question. It's a 1 mark question related to linked list, like singly linked and doubly linked list. Come on. Let's try to read the question. What is the worst case time complexity for the deletion? That is the question. Okay. Come on. I'm giving you few minutes, like few seconds to think. Come on, try. Okay, so before let's discuss the basic conceptual knowledge regarding the linked list. Okay, regarding linked list, let's try to understand the concept. Say if I've been given a linked list like this, so it's say this is a concept. Okay, so this is and here also same drawing. It's like this. Okay, now the question is, let's say we are having nodes also like C, E, F. If I would like to delete this node in a single linked list. Okay, if I would like to delete this node, so how I have to do, say I have given you head pointer and this node, okay, that I will delete this node and this is head pointer. Okay, so now if I'm starting from the head node and now I would like to delete the node E. Can I directly delete the node E? Come on, can I directly delete the node E? No, I have to start from the beginning. I have to start from the beginning so that I'll reach node E and then I can delete it. Correct? Yeah. So that's why deleting a node in the case of single linked list will take order of n time. And how deletion happens? Come on, how deletion happens? So we all remember, like we used to traverse like this. This used to be previous and this used to be current. So what we used to do? We used to do something like previous dot next is equals to current dot next. Okay. So like this is how we used to do, so that the linking will happen like this. So that's how the node gets deleted. Okay. But so that's why can I say that single linked list I will require to traverse the list from the beginning to delete the element? Yes. Okay. Yeah. Now let's discuss about the doubly linked list. In the case of doubly linked list, what is the basic concept? I will be having the node, but I will be having the pointer to the previous also. Like this will be happening. So it's like this and like this. So say if I would like to delete this node, and say this is my previous node and this is my current node. Like this is my current node that I want to delete, and let's say this is my next node. So I have the access to the previous node. So let's say if my head is somewhere, if my head node is like here, so I don't need to traverse all the way from head node to current node to delete this node. Why? Because access to the previous node can be already been given from the help of doubly linked list. Okay, so that's why what I can do, I can simply say that okay, whatever is my current node's previous next should be this guy. Okay, and this guy's previous should be this value. So that's why if you want to perform delete operation in the case of doubly linked list, you don't need to traverse the list from the starting. So that's why deletion in the case of doubly linked list is constant time order 1, But in the case of singly linked list, it's order of n times. So that's what they are saying. Which one of the following choices is true about the worst case time complexity of the singly linked list? Delete and doubly linked list delete. Okay. So can I say that D is correct? Singly linked list deletion is order of n time, and in the case of doubly linked list, it's constant time. Okay. Yeah. Okay. Another theoretical question, students, is regarding minimum number of collision. Let's read the question. An algorithm has to store several keys generated by an adversary in a hash table. So you have to store several keys over here. Now the adversary is malicious who tries to maximize the number of collisions. We all know what is collisions in the case of hash map or like hash table. Like we use some hash function to store the values, and if the keys are mapped into the same slot, then collision occurs. Okay. Now what they're saying, let k be the number of keys. Let k be the number of keys and be the number of slots in the hash table. Like I am having number of slots in the hash table as m, and the number of keys is k. So n k is greater than m. Now, which one of the following is the best strategy to counter attack the adversary? Means which one of the following strategy I should use so that the number of collisions is reduced. Okay, so division method, first option is division method. Use the hash function h of k as k mod m. Can I use that, students? Can I use that? No, right? Yes, because in this case also we can have any collisions. So we do not give any information about what is m, what is k. So it is depending upon the key, and then we're doing modem. Say if m is 10, so whatever is a multiple of 10, they can map to the same location. So that's why division method is in like it's not the best way. Okay. Similarly, multiplication method they're saying where the hash function h of k is m times k of a with some function. Okay, where a is carefully chosen constant. So even in this case also, there will be too many collisions happening. Okay, using like universal hashing method. What is universal hashing method? Like universal hashing method are such method or like such functions which are independent of the keys. Say if there are some n functions and I'm selecting randomly some function and computing like where the particular key should be placed, and it is independent of the key. Okay, so that's why like C is one of the options. Yes, C is correct. Like to counter attack the adversary. So yeah, if k is a prime, use division method. Otherwise, multiplication method. No, so in that case also we will be having problem. Okay, so yeah, that's why C is correct. Yes, can we proceed? Yes, students. One very basic question related to the C programming. What is the output of the following program? Can we try? Can we try, students? It's related with static variables. Come on, try. Static variables, students. Come on. See, let's discuss, students. Let's discuss. So there are two local variables. So let's try to draw with the help of blocks. So this is x, and then this is y. So these are local. Okay. And let's say I'm drawing another x, which is static. Okay, so yeah, let's discuss. So initially x and y are local variables, just has been declared but not initialized. Okay, now x is equals to function p. So it will be call will be happening over here. Then what I'm doing, static integer x is equals to 1. So what will be happening, x value will be 1 over here. Okay, now x will be incremented. So 1 will be incremented to 2. Okay, so now what value will have been written? 2. So can I say x value is 2? Yes, do you all agree? This is local variable I'm saying. Okay, now x plus plus also happened. So can I say the static variable also value would have been updated to 2? Yes? Yeah. Now I'm calling what? Again, y equal to function of p, function p plus x. So now call will be coming over here, function p. Okay, now will x be initialized to 1? Come on, will x be initialized to 1 again? No. Okay. Why? Because we discussed static variables like the scope remains till the lifetime of the program. So in this case, this, you can assume that this won't be getting executed and x value 2 will be retained. So when I'm doing x plus plus, so now this x variable would be updated to 3. Okay, yes, correct. Now I'm returning x. So can I say this return function value would be 3? Yes. And what was the value of x? Local x 2. So can I say 3 plus 2 5? This is the value of 5. Yeah. So now what I'm doing, printf x plus y. So x plus y 2 plus 5 7. So in this case, the answer is 7. Okay, very simple question. I hope everyone got it. Yeah. Okay. Now again, let's read the question. It's related to the activation tree record. So we have been given a main method, and inside that we have 3 functions. Okay, and like corresponding function definitions has been given. So we have to draw the activation tree. I'm just giving you a look in the options. So how does this looks? So like some similar to this, we have to draw the activation tree. Okay, so now let's read the question and think and try to draw the tree. Come on, try. Yeah, let's try to draw the students. Okay, no problem. See, if I'm having a main method, okay, I'm having a main method over here. Now what will be happening is that main method will be called, first main will be getting executed. So now linearly how it is happening, f1 is executed, then f2, then f3. So f1 will be called here, then f2 will be called, then f3. Okay, so this is like this. Now let's talk about f1. How f1 is doing? F1 is simply returning 1, that's all. Okay, so nothing big over here. Now f2 of 2. Now f2 is internally calling f3. Okay, now once f3 is calling, f3 is calling. Okay, now f3 is what is doing, simply returning 5. Now after f3 what is happening, come on, after f3 based on some conditions, either it is being called f2 and then f1. Initially like it is being provided 2, so can I say that after f3 it will be called f2? Yes, and from f2 it will be called 2 again. It will be called f3, and then now f3 will call f1. Okay, so let's see which option suits better. Come on students, which option suits better? See, we call main method, and then we are having f1, f2 and f3. Okay, now from f2 we'll be calling f3 and then f2. Okay, then from f2 I'll be calling f3 and f1. So this is f1. Okay, yeah, and f1 is what? It's simply returning. So let's see which option suits better. Now f2, yes, so a option is correct. Okay, so among a and among d, like which is better, which is correct guys? F2. Let's see, f2 is calling f3 and f2, and then again f2 is calling f3 and f1. Okay, so that's why a is the correct option. Okay, any doubts students? Okay, so yeah, let's proceed to the next question. It's regarding the priority queue maximum heap related question. Come on students, let's try together. So what they're saying that let A be the priority queue for maintaining a set of elements. Okay, now suppose A is implemented using a max heap data structure. Is implemented using a max heap data structure. Now the operation extract max, like what it's doing, it extracts and delete the maximum element from A. Okay, so again, max heap is not just getting what is the value in the root, we are getting it and we are deleting it also. Okay, now the operation of insert, A of key inserts a new element key in the A. Now the properties of a max heap are preserved at the end of each of these operations. Okay, now when A contains n elements, which one of the following statements about the worst case running time of these two operations is true? Okay, come on students, come on. So can I say the question boils down to that What is the delete? What is the time complexity to perform delete operation in the heap? What is the time complexity to do the delete operation in heap? And what is the time complexity to insert, like insert an element into the heap? So insert operation and delete operation. So what is the time complexity? Come on, students, come on, think. Okay, let's discuss. Not a problem. See, it's always a heap, right? So we discuss, let's say this is the elements, and say if I would like to perform an insert operation. So what will happen that at worst case, what will happen that this inserted element will be my root. So what will happen is that I have to traverse my entire height of the tree. And what is the height of the tree in the case of complete binary tree? It is log n. It is log n, students. Okay, so that's why can I say insertion will take maximum of log n time? Yes, insertion will take log n time. Okay, now delete operation in the heap. Delete operation, how it will happen? Delete operation always happens from the root. Like we'll keep it at the lastmost element, like we'll keep at the last and then we will rearrange it. So that in this case also maximum I have to traverse is the height of the tree, which is log n. So can I say students that in this case um, both the operations are taking log n time? So let's check which is correct. No, order of one is not there. Log n is also not. Extract maximum of a runs in order one. Yeah. So which one of the following is case is true about the other cases? So in this case, both will be running in the sorry log n time. This is log n. So my bad. Yes, in this case, B is correct. Okay. So both extract max and insert will run in log n time because the height of the tree will be log n. Okay. Yeah. Good. Yeah. Let's discuss this question. Consider the C function foo and the binary tree being shown over here. Okay, yeah. So yeah. So we have first traverse, see the code, then I will say what is the options and or what is the question. Okay, come on. Okay, we have read it. Yeah. So the question is that when the foo is called, when the function foo is called with a pointer to the root node of the given binary tree, then what it will print? What will it print? Come on. So you got the question, right? Say if my node, like if I'm been given a tree, if I've given a tree and I'm passing it to the root, and I'm passing, like when I call this foo method, I'm passing the root. Okay, so now what will be the answer in this case? Okay, let's consider scenario that if the root would have been null, like I know this tree is being given, but say if the root is null, then what would have been the answer? What would have been the answer, students? It would have been just printed 0. Okay, now let's assume there would have been only just one node, 10, only one node 10. Okay, no, nothing children is there. So in this case, what would have been the output? Come on, students, in that case, what would have been the output? So let's say if I've been given 10, like this is null. Okay, nothing is there. So what I would have done, like in this case it is not null, so retrieval of what? P of value would have been 10, then P of left, and then P of right. Can I say they both are null? So in this case both would have written 0 and I would have just printed 10. Yes. Now let's discuss one more time. If I assume that there would have been only 5, okay, no right child. So in this case what would have happened? Again the control would have come here, then 10 would have printed, then 10 plus left child, so it's foo of 5. Okay, plus foo of null, because there is no right child. Okay, so now what would have happened? Then again we would have called foo of 5, then 5 value is there, then 5 is not null, then again it would have done of this call, like 5, this 5 is have any left child or right child? No, so for 5 plus foo of null plus right of null. Okay, so they both would have nulls, it would have returned 0. So in that case, we would have printed first 5, then we would have returned 5. So in this case, it would have been 10 plus 5, which would have been 15. So can I say first 5 got printed and then 10 got printed? Do you all agree with me, students? Yes. Okay. So what I want to emphasize is that, and then behind the scene, what is happening? You just take the root, compute the values, and print it. Okay. So what is happening that, can I say that what is a, see, first we are printing the 10, then we are printing the left subtree, then we are printing right subtree. Like we are calling left subtree, we are calling right subtree, get the values, and then we are printing. So can I say students that all the values will be added first? So like 10 plus 5 plus 11, 3, 8, 13, all values I would have added. And can I say it would have printed at the last? Because why? Come on, why? Because it's a recursion. Okay, I'm giving call to the left child, then I'm giving call to the right child, and all these things. So can I say students that first, like left subtree I will be like going, then right subtree I'm going, like initially I will be going all these things, and then I would have printed the every value. So let's sum up all these things. As we all agree that sum of all the elements whenever we'll be adding, sum of all the elements when we'll be adding, that will be printed at the last because of the recursion. So 10 plus 5, when you add up all these things, how much it is? 10, 11, 21, 13, 34, 34, 8, 42, and then this is 50. So can I say students 50 would be printed at the last? Yes. Okay. So now let's check the options. In which of the cases 50 is getting printed at the last? Yes, C option. Okay, so that's why C is correct. Okay, for the option, like sometimes you have to filter the options also to get it to move into the correct next questions. Okay, so that's why I started with the very first node. First I started that what if the node is null, how we will be handling. If there is a non-null node, how will be happening. And then if it is a left child, then if it is a right child, then how things would have printed. So in that case I'm saying, okay, so that's why the correct answer is C. Okay, so here also you can see, so how it will be happening that first left child will get printed, then right child will get printed. Okay, then sum of all these things will be printed. So first 3, then 8, then 3 plus 8, 11, 11 or 5, 16. Okay, so 16 would be printed. Okay, so first 16 got printed. Then once this is done, of P of left is done, then we'll do the right subtree traversal. So here also first 13 would be printed. Yes, then 11 would have been printed. Okay, then come on students, then what will be happening? Then sum of all the elements. So like foo of left, right, and then it is happening. Okay, I hope it's very clear. Yes, yeah, good. So yes, for this the correct option is C. Okay, yeah, come on. Let's discuss this question, students. Consider a sequence A of elements we have been given and the following operations we are trying to perform on the stack. Okay, on a stack S and a queue Q, both of which are initially empty. Okay, so now the scenarios that is happening is like we are pushing the elements, in queuing the elements, pop, dequeue, all these things are happening. Okay, similarly this thing is happening, then the top of the element of S after executing the above operations is. Okay, come on, try. Just a moment. Yeah, this is the question. So we have a sequence of elements being given. Okay, Yeah. Yeah, let's discuss, students. So what we are doing, we have been given some elements like A0 to A5. We have been given 6 elements. Okay, we have been given 6 elements, students. So what they're saying, the following operations are performed on a stack S and a queue, both of which are initially empty. Okay, so now push the elements of A from A0 to A5 in that order into the stack S. So I have a stack and I'll be pushing the elements like 1, 5, 7, 8, okay, 9, and then 2. Okay, so these are the elements being pushed. Similarly, like this is my stack. Okay, now what I'm doing, like in the queue I am inserting also. So 1, 5, 7, 8, 9, and 2. Okay, so this is stack and then this is queue. Okay, now what we are doing, pop an element from S. So can I say 2 would have got removed? Yeah, so 2 is being removed. Okay, now dq an element from S. So in like q follows which principle? It's first in first out. Okay, so which was the element first, that will get removed. So this is the front pointer and this is the rear pointer. Okay, so which will get removed? One will get removed, so front will be coming here. Now again we are doing pop. So can I say 9 would have also got removed? And again I'm doing dq element. So can I say dq? So dq again 5 would have got removed and my front would have come here. Okay. So to be more clear, what is happening, that current state of the stack is like 8, 7, 5, 1. Okay. This is my current stack. And what is the current scenario of q? What is the current scenario of queue, students? Like we have performed 2 times the DQ operation, 7, 8, 9, 2, it's here. So this is my queue operation, 7, 8, 9, 2. So what they are saying, DQ an element from queue and push the same onto the stack. So 7 we are deleting, okay, and pushing it to the stack. 2 an element from the stack and push it to the same element onto the S. Okay, so we have DQ and front pointer would have come here. Okay, so let me draw over here. So 1, 5, 7, 8, and again 7. Okay, now what is happening is the following. So 7 we inserted, now front is there. Now what they're saying, repeat the operation 7 3 times. Means you do the DQ operation and insert it over here. DQ and insert, DQ and insert. So then can I say 8 will be inserted, then 9 would have inserted, then 2 would have inserted. Yes? Do you all agree? 8, 9, 2 would have been inserted. Okay. Now pop an element from S and pop an element from S. So can I say 2 would have got removed and 9 would have got removed? So what they're saying, the top element of the S after executing the above operation is. So what is the top element? Can you say top element is 8? Yes. So the answer is 8. Okay. Yes, students, any doubts? Okay. So yeah, I think we have covered a question that has been asked in the programming data structures and algorithms in the GATE 2023. But just we'll do a quick revision with respect to the what questions we have covered today. Okay, so that if you have any doubts, you can ask one more time. Okay, we can have a look. Okay, so let's do the revision quickly. Yeah. So again, the first question was very basic, related to the f of n and g of n. It was related to the asymptotic notation. So since one function was linear, another one was quadratic, so like we can always have a big O notation over here. So for big O, like in this case, little o was also applicable. Okay. Similarly, second question was also in the case of how many times x plus 1 got executed. So first one was the GP series, another one was simple linear. So both were in the order of n. Okay, so that's why A and D were the correct options. Okay, because in like theta has the equality case also, and like everybody, big O also, big O and omega. Yeah. So this was a very beautiful question, and in the case of power set of U. Okay, so 2 power U denote the power set. So what are the various BFS orderings possible? Okay, so we found out we all know that phi, like the empty set, is a proper subset, like is a proper subset of every other set. Okay, is a proper subset of every other set. So what we found out, that again, if I'm having n elements, so how many elements in the power set of that set? It will be 2 power n. Okay, so in this case I'm having u is equals to 3 elements, so 2 power u, so I'm having 8 elements. Okay, including empty set. So empty set will be connected to how many vertex? It will be connected to 7 vertex. Why? Because phi is a proper subset. Okay, so when we were doing the BFS sorting, we found that since we have to start from phi, and phi can be connected to all the 7 elements, so how many ways? 7 factorial. Okay, because we can start from any of the vertex. Okay, yeah. Yeah, so this was a question we covered. Then we came to programming and data structures. Here, one very basic questions they have asked students related to the forming of a maxip. So if we know the property that parent should have more value than its children, then definitely it was a very trivial question, and we got the option B as correct. Okay. My homework to you guys is like, say if they have given the maxip. Okay, if the question would have been given as a mean heap. Okay, if the question would have been mean heap, so which of the following option was correct, or no option was correct? Okay, think about it after the class. Okay, and let me know. Yeah, so this was the one question, and another basic question was asked related to the linked list, where we covered like, if I've been given a single linked list and if I would like to delete, so what is the time complexity? Since in the case of single linked list, if I'm at a particular node, I can't go to the previous node directly. I have to traverse it from the beginning. So that's why deletion of, in the case of single linked list, takes order and time. But in the case of double linked list, I can simply go to the previous linked list, previous node. So that's why it will be order one. Okay, so that was the question we covered. And this question we covered related to the hashing strategy, like what should be the hash function we can use so that we can avoid the collisions. So it was a case of universal hashing method. Okay, universal hashing method, students. So that's why because this method is independent of the key, and so it reduces the chances of collisions. Then we covered very basic concept related to C programming, like output based question. So in this case, the static variable, like there was a variable static, and we all know that the scope of that variable is the lifetime of the program. Okay, it's not restricted, it's not like local variables. If the function get executed, it will get out of memory. Nothing. Stack memory scope is like stack scope is till the application program. So when we do x is equals to 1, we are doing x plus plus. So when next time this function gets called, so again x won't be initialized to 1. Whatever is there in the memory, it gets executed. Okay, yeah, so that's why we got the relevant answer in this case. Yeah, then we covered the question related to the activation tree, like how the sequence of function calls is happening and the corresponding tree we have drawn. Okay, students, in the case of such question, if it comes in the gate, what we have to do is like, just have a main function as a root, just follow the calls, just follow the calls and draw that tree. Okay, you'll get the answer. In such cases, don't, like from the option, don't select the answer. In such cases, from the question, try to draw the tree and then you get the answer. Okay, yeah, so that was the one thing we covered. And yes, then they have asked a basic question related to the max heap, like the typical operations that we perform, like insertion operation, deletion operation. Okay, so what is the time complexity? So we all know that when we want to insert, so worst case scenario is the height of the tree, so that inserted element can go to the top. So that's why insertion takes log n time. Similarly, deletion also, it may require to go up to the top. Okay, so that's why it's always a log n operation. So both takes log n time. And next question we covered was the binary tree traversal. Okay, so in this case, we were able to quickly solve the question by eliminating the options. Okay, that if this is the case, so what should be the last output, what should be the first output? So if you see, then we can definitely got the correct answer. So but again, the conceptual manner, what is happening, that we are trying to calculate the sum of the elements of the tree. Okay, but every time we are printing also based on the particular node being provided. Like if I'm traversing the left subtree, so what is the value? If I'm traversing the right subtree, what is the value? So that things we have covered. Okay, yeah, so this was a thing. And then we covered a very basic question related to the stack and queues. If you just follow the sequence being given, so yeah, in that case, we can get the answers. Okay, so it was a very basic question. I think it was being asked for the 2 marks. I don't remember. Yeah. So yeah, I think students, yeah, thank you so much for joining, and I hope this session was fruitful, and we were able to do a quick revision regarding the previous year question, which was asked in the GATE 2023 in the computer science paper. Okay, so we wish you all the very best. I know time is left like in a week or two, exams are coming. Keep preparing hard, and yeah, all the best. We are always there for help you. Take care. Bye bye.